Hello, good day everyone. My name is Teacher Nat and today we're going to discuss systems of linear equation in two variables. Okay, so we can use systems of linear equations in two variables to help us solve some problems we might have in our, everyday life, like everyday lives. I mean, like for example, problems about profit and loss of a company or problems about household income and expenditures. So those are like problems that we will be dealing under this topic. Actually, to find the solutions of the systems of linear equations in two variables, there are three methods. We have elimination, we have substitution, and graphical method. First is I'm going to explain to you about the first method, which is on elimination. So elimination means we're going to get rid one of those variable in order for us to find a solution. So eliminate means delete, erase, get rid, and yeah, those are the words that will be best describe to this method. So we know that, for example, here in number one, we have two equations. Let's say equation number one is 3x minus y is equal to 10, and equation number two is 2x plus y is equal to 15. So since we are going to use elimination, so as a student, you need to decide which variable is easier for you to eliminate, okay, or get rid. Actually, as you can see, we know that in the loss of integer, it's easier for us to, or we can eliminate numbers if we have the number and given its opposite. So when you add them together, a number and its opposite is equal to 0. So obviously here, as you can see, we have the coefficient of y in the first equation. If the coefficient of y in first equation is -1, and the coefficient of y in the second equation is +1. So obviously if we add them together, we will get 0. So we are going to eliminate y. So if we're going to add equation 1, so we add equation 1 plus equation number 2. So we will have 3x minus y is equal to 10, and we have 2x plus y is equal to 15. So since we're going to add them together, so that will become 3 for x's, so we have 3 and 2, so we add them together, so that is 5x. So this will become 0 for y, and then we add the constant, which is equal to 25. We have 5 as the coefficient of x, so we will divide both sides of the equation by 5. So we will have x is equal to 5. Now we have the value of x already, which is equal to 5. Now the second thing we're going to do here is to find the value of your y, because we have already the value of our x. So to find the value of y, we simply choose one of those equations. Let us say we will use equation number 1, for example, which is 3x minus y is equal to 10. Then we will replace x with 5. So we have 3 times 5 minus y is equal to 10. So we have 15 minus y is equal to 10. And then we have now negative y transpose 15 on the other side. So we have 10 minus 15 is negative y is equal to -5. Or since we have negative y, we will multiply -1 to have y is equal to 5. Now, to check whether these values for x and y is really a solution of the equations, we are going to replace the value of your x and y in either of those equations. So let us say we will use equation number 2. So we have 2x plus y is equal to 15, and then we replace x with 5. So we have 5 plus y is equal to 5 as well, so that is 15. So we have here 2 times 5 is 10, plus 5 is equal to 15. So 15 is equal to 15. As you can see, the values of x and y satisfy the equation. So we can say that, therefore, the solution of this linear equation is actually 5 and 5. Thank you.
For system of linear equations number 2, we have 2x minus 3y equals 12 and x plus y equals 8. Our target here is to eliminate one variable, and in order to do that, you have to multiply one equation so that one term of the other equation would have an opposite sign of the same term in the second equation. So in my case, I'd like to eliminate x. So in this case, the coefficient of x here is 1, invisible 1, and the coefficient of x in the first equation is 2. Our target here is that the second equation will have the same coefficient yet have the opposite sign. So our target here is to make this x will become negative 2. What should we do? Since we want to make it a negative 2, we multiply negative 2 to every term in the equation. So we multiply negative 2 to the first term, to the second term, and even to the third term. So in that case, that would become negative 2x minus 2y equals negative 16. Copy the first equation, which is 2x minus 3y equals 12. We have 2x here, we have negative 2x here. In that case, it's easier for us to eliminate, knowing that they have different signs now. As we know, positive 2 and negative 2 added together will become 0. So we eliminate. Add the remaining variables. Negative 3y plus negative 2y, that's negative 5y, equals 12 minus 16, that's going to be negative 4. In order for you to get the value of y, we divide both sides by the coefficient of y, which is negative 5. Do not forget to include the sign. Negative 5 divided by negative 5, that's 1. But instead of writing 1, there will be an invisible 1 beside y. Negative 4 divided by negative 5, that's going to be 4/5. Because negative divided by negative, that's positive. So negative 4 divided by negative 5 becomes 4/5. We already have the value of one variable. Our second step is to substitute 4/5 to either of the equation. You may substitute it to the first equation or to the second equation. Let's try first the first equation. We have 2x minus 3y equals 12. Let us substitute y to the equation. That's gonna be 2x minus 3 times 4/5 equals 12. Multiply. 3 has an invisible denominator 1. That makes 12 over 5 equals 12. For me, it is easier for me to multiply every term by 5 so that I won't have fractions anymore, because I really hate fractions. So I'll multiply 5 to every term. 5. So I multiply this. It's gonna be 2 times 5, that's 10x. Cut, that's gonna be 12. And this is gonna be 60. Transpose 12 to the other side of the equation. 10x equals 60 plus 12. 10x is equal to 72. Divide both sides by 10. X now is equal to 36 over 5. So these are the equation. Our ordered pair now is 36 over 5 and 4 over 5. Got it?
Now we have the values of x and y, and let us check whether this ordered pair will satisfy the given equation. Let's choose equation number 1, for example. So we have x plus y, equation number 2 is equal to 8. So we will replace x with our value here. So we have 36 over 5. and then plus our y is equal to 4 over 5 is equal to 8. So adding them together, so we will have like 40 over 5 is equal to 8. So that is 8 is equal to 8, which therefore we can say that the solution of the given linear equation is 36 over 5 and 4 over 5. For example number 3, it is more complicated compared to example number 1 and example number 2. In example number 1, what we did is we eliminate directly. In example number 2, what we did is we multiplied a number so that we will get the opposite of, or the opposite of your numerical coefficient that you want to eliminate. For number 3 here, you can first you need to make decision which variable you're going to eliminate. So if you decide, for me, I will decide to eliminate, let us say, my variable y. So if I'm going to eliminate variable y, I need to identify the LCM of the numerical coefficients of y's. So we have 2 and 3, right? So the LCM is 6. So what I'm going to do is, if I'm going to consider equation number 1, I want to make 6 here. So I will multiply 3 to equation number 1. So 3 times equation number 1. And I'm going to add it with equation number 2. But to make this one 6, I will multiply 2. But I need to have opposite, right? In order for me to eliminate y. So I will multiply, instead of multiplying 2, I will multiply negative 2 to equation number 2. And then I will add them together. So if I'm going to multiply 3 to equation number 1, so I will get a new equation which is now 9x plus 6y is equal to, I multiply 3, that's 18. Okay, so I multiply, here I will multiply 3, right? And then in equation number 2, we decided to multiply negative 2, as you can see here. So if I multiply negative 2 with 4x, so I will get negative 8x minus 6y. And then I will multiply negative 2, right? So I will get negative 4. So if I'm going to add them together, what will happen now is that this will become x. This will become, our y will become 0. So that is equal to 14. So we have the value of our x now, which is x is equal to 14. Now, again, the same step we're going to follow 1 and 2. We need to use either of the equations and then replace the x with 14. So we will, let us say if we're going to use equation number 1, for equation number 1 here, we can use 14 for x. So we have equation 1 is 3x plus 2y is equal to 6. So we have 3 times 14 plus 2y is equal to 6. So I have 12 carry 1, 42 plus 2y is equal to 6. So 2y is equal to 6, transpose 42 minus 42. 2y is equal to 36 negative. And then we will divide both sides with 2 as the coefficient of y. So y is equal to negative 18. So let us see or check whether the value of your x and y will satisfy either of those equations. So let us say we will use equation number 2, for example. Equation number 2 is 4x plus 3y is equal to 2. So we'll replace x with 14. So 4 times 14 plus our y is equal to negative 18 is equal to 2. So this one, 4 times 14 is equal to 56 plus, or it will become minus because that's negative 18. So negative 4 carry 2, 54 is equal to 2. So 56 minus 54 is equal to 2 is equal to 2. Therefore, it's checked. So the solution of the equation is actually, the solution is 14, negative 18. So that's all for this topic, and I'm going to give you exercises for you to submit